Hello, you are welcome to my channel. Now, I have a question here under vectors, resultant of forces. Now, the question says, find the resultant of the set of forces shown below. Now, we have four forces here, four of them acting at angles to this horizontal level. This is the horizontal level. So we have 12 Newton acting at 60 degrees to the horizontal. We have 7 Newton acting at 40 degrees to the horizontal. We have 5 Newton acting at 75 degrees to the horizontal. And we have 8 Newton acting at 48 degrees to the horizontal. Now, for us to solve this and get the resultant, we have to create a table like this that we can use to get the required values. Now, let's fill in the values for this table. Now, if you check, this is F, which is the force is given. So I have the 7 Newton force there. I have 12 Newton. I have the 5 Newton. And then finally, the 8 Newton force. And then we should also represent the angle that they have. So the 7 Newton is 40 degrees to the horizontal. The 12 Newton is 60 degrees to the horizontal. The 5 Newton is 75 degrees to the horizontal. And the 8 Newton is 48 degrees to the horizontal. Now, it is very, very important that we remember quadrants. Now, I'm just including this quadrant so that it can help us to know where each of these forces fall to, which quadrant. And then that can help us to signify the signs of the horizontal and vertical components of the forces. Now, the 7 Newton force is in the second quadrant. The 12 Newton force is in the first quadrant. The 5 Newton force is in the third quadrant. And finally, the 8 Newton force is in the fourth quadrant. So now that we have their quadrant, we can now assign their horizontal and vertical component signs, the sign of their horizontal and vertical component. Now, for this, you should remember that we have this first quadrant here, using this plus now. This is our first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. Going from this point in an anti-clockwise direction. So now, you agree with me that here, all of them are positive. That is both cosine, tangent, and sine. They are all positive here. But in this second quadrant, only sine is positive. In this third quadrant, only tangent is positive. And in this fourth quadrant, only cosine is positive. So this all sine, tangent, and cosine can also help us in assigning the positive and negative sign to these values using this quadrant method. So the vertical components in the second quadrant, the vertical component, this F subscript Y means the vertical component, and F subscript S means the horizontal component. So in this second quadrant, that is this now, the vertical component is positive, while the horizontal component is negative. So you can see now that in this direction, the vertical component of this force will act upward here, while the horizontal component will act in this direction. That makes it negative and this one positive. So in the same way, in the first quadrant, all of them are positive. So both vertical and horizontal components are positive in the first quadrant. And then in the third quadrant, there, only tangent is positive there. So that will tell us that both sine and cosine are negative in the third quadrant. And then finally, in the fourth quadrant, that is this quadrant now, only the horizontal component in this direction is positive, and that is cosine. And then the vertical component, which will act downward here, is negative. So these are the signs. So take note of these. If you are able to remember these signs, it will help you in getting the vertical and horizontal component in problems like this. So now we can use these signs now to obtain our vertical component. Don't forget, the formula for vertical component is F sine theta. That means the force multiplied by the cosine of the angle, the sine of the angle. So now the force I have here is 7. So I have 7 sine 40 because the angle is 40 and the sine is positive. Don't forget, this is F subscript. So we are looking at the whole of these signs here. So we'll be using this. So this sign is positive. So I'm simply going to write 7 sine the angle, which is 40 degrees. That's the angle 40. And 7 multiplied by the sine of angle 40 degree will give me 4.500. 4.500. And then the second one now, using the same, this is also positive. So I'm going to say 12 multiplied by the sine of 60. So it's going to be positive 12 because the sine here is positive, multiplied by the sine of angle 60 degrees. And that will give me the value 10.39. 10.39. And then the third sign here is negative for the vertical component. So it's going to be negative sine multiplied by the force, which is 5, and then sine the angle. What is the angle here? 75 degrees. 75. And that will be equal to minus 4.830. Minus 4.830. So that is what this part will give us. And then finally, the last one is also negative. So I'm going to say the negative of 8, that's the negative of the first, negative 8 multiplied by the sine of the angle, which is 48 degrees. And that will be equal to negative 5.945. 5.945. So that is the value here, negative 5.945. Now that we are through with the vertical component, let's move to the horizontal component. Now, for us to handle this horizontal component, we are also going to apply these signs here. So the first sign is negative. Don't forget, horizontal component is the force multiplied by the cosine of the angle. So while vertical component is the sine of the angle, horizontal component is the cosine of the angle. So the first sign here is negative. So I say minus 7, which is the force, and then cos multiplied by cos, the angle is 40. And that will give me minus 5.362. Minus 5.362. That is the value it will give me. So let me just simply put is equal to here. So it's equal to minus 5.362. And then the next one here, the sign in this case is positive. So I'm simply going to write 12 cos 60 because it is positive. So I simply write 12 and then cos. The angle in this case is 60 degree. And that will give me exactly 6 as the value. The third one is negative. This is negative. So I'm going to say negative 5. So I have negative 5 multiplied by the cosine of the angle 75. And that will give me minus 1.294. It's equal to minus 1.294. And then finally, the last one is positive. So I'm simply going to take positive 8 multiplied by the cosine of the angle, which is 48. And that will be equal to 5.353. 5.353 as the value. Now that we have all the horizontal components and all the vertical components, what we simply need to do is to add all the values of the vertical components. So I'm going to call it summation, this symbol, summation f of y will be equal to, so when we add this 4.5 and this 10.39, negative 4.83 and negative 5.945 is going to give us positive 4.115 as the summation. Similarly, when we add all these values for the horizontal component, and I'll call that the summation of f of x, that is the summation of the horizontal component, is going to give us 4.697 as the total value. Now that we have the total values, we can now go ahead and find the resultant of the forces. The resultant of the forces. And the formula to apply. There's a formula for this resultant, and that formula is R is equal to the square root of the summation of f of y squared. That is the summation of what we got here. We square it plus the summation of f of x all squared. So the square root of this will give us what we are looking for. And then you agree with me that with respect to that, we can simply say that is equal to the square root now of the sum of f of y is 4.115 squared plus that of f of x is 4.697 squared. So by the time we square this and also square this and add them together and take their square roots, it's going to give us the resultant of the forces. Going to give us the resultant of the forces as 6.24. 6.24 Newton. So this is the resultant of the forces. And then if we want to get the angle of this resultant force, we want to get the angle that it is acting through, we can simply use the formula for the angle and say the angle is equal to the tan inverse. The tan inverse of the summation of f of y all divided by the summation of f of x. So the tan inverse of this division will give us the angle that we are looking for. And that will be the tan inverse of the summation of the f of y value, that is 4.115. 4.115 all divided by that of the x value, which is 4.697. So when we divide this and take the tan inverse, it's going to give us the angle that the resultant acts through. And that will be equal to 41.2 degrees as the angle. And that is the final answer. So this is the resultant for 6.24 Newton. And this is the angle through which the resultant acts. And that gives us the final answer of this question. Hope you enjoyed this video. Please don't forget to like and share this video so that others can learn from it. And don't forget to also subscribe to this channel for more videos like this. Thank you for watching.